Hi, this is Mr. Manley. In this video, we're going to look at finding the zeros of a function that is not quadratic and cannot be factored. So you should recall from previous study that if we are solving specifically a polynomial, what we want to do is we want to factor, and then we're going to set it equal to 0. If I cannot factor and it's a quadratic, that's where the quadratic formula comes in. Now this is only true for a quadratic polynomial. So a polynomial that could be written in the form ax squared plus bx plus c, f of x equals. If we do not have a quadratic that is an exponent of 2, then all we can try and do is factor. So let's take a look at that with this one here. So something else that you should know, if you have a polynomial that is not quadratic, that would be a higher degree polynomial, x cubed, x to the fourth, x to the fifth. One of the things that we can try is to try grouping. So if I were to group this into pairs like this, and then look and see if I can factor the pairs. But I can't factor the pairs here. So at this point, I'm really stuck. It's not a quadratic and I can't factor it. But we have found that there is something called the rational zeros theorem, which allows for solving a polynomial if it has a rational zero. Now, it might not have a rational zero. And remember, every time I say the word zero, that means solution. And every time I say solution, that means that if I plug in that value of x into the expression, it will equal 0. Okay, so keep that in mind. All right. So what is this rational zero theorem? The rational zero theorem says that if a polynomial has a rational zero, and it might not have a rational zero, it might have an irrational zero. So it might have a zero that is a radical. It might have an imaginary zero. But if it has a rational zero, it has to be one of these. What is one of these? One of these is I take the constant term. So the constant term, all right, that's the term without a variable. And I look at all of the factors of the constant term, including 1. So 1 is a factor of 7, and 7 is a factor of 7. And I look at all of the factors of the leading coefficient. Okay, so this is leading coefficient. Well, what are the factors of 6? 1, 2, 3, and 6. And then what I'm going to do is I'm going to look at all of the variations of the constant factors over the leading coefficient factors. All right, so let's look at what that looks like. I'm going to clean this up a little bit. And I also am going to say that I'm always going to look at plus or minus. So look at that, plus or minus the constant factor over the leading coefficient. So if I were to say, what are the possible rational zeros? Possible rational zeros. They're going to be constant factor over leading coefficient. There's one possibility. This 1 over that 1, which is really 1, right? And I'm going to say, again, remember back here, I'm going to say plus or minus. So plus or minus 1. Then I'm going to do all of the possibilities here. 1. Now I did 1 over 1, right? Now I'm going to say, well, 1 over 2 is a possibility. I'm going to go plus or minus 1 over 2. And then 1 over 3. Plus or minus 1 over 3. And then hopefully you're following along now. You can see what I'm going to do next. Plus or minus 1 over 6. And that eliminated the 1. So I did everything that I could with 1. 1 over all of these. Now I'm going to switch it up and go to the 7. 7 over 1. And then I'm going to run through all of those possibilities. So it'll be plus or minus 7 over 1. Plus or minus 7 over 2. Plus or minus 7 over 3, and plus or minus 7 over 6. Okay, so if this has a rational root, it will be one of these. And I would find out if it is one of those by what? Well, you may remember from a previous lesson something called the factor theorem. And the factor theorem said if P of C is equal to 0, then X minus C is a factor of P of X. I think that if you stop and try and digest what has been said here, you can understand it. And if you understand it, you'll be able to do problems that use these concepts. So I've got these possible rational roots. I've got the factor theorem. Can you guess what we're going to do? That's a nice thing to always do when you're listening to information, when you're getting new information, learning a lesson, is to try and guess what's going to happen next. The other thing is to ask questions. So certainly if you ever have questions when you're having a lesson, as you are now watching this video, write your questions down. And they can't be too general. You can't just say, I don't get it. You want to try and devise a specific question. So what am I going to do next? I'm going to start testing these. So I'm going to try P of 1. And and what does that mean? Well, it's not P actually. In this case, it's H. Okay. So go ahead and get with the program on the notation for this particular function. So I'm going to look at H of 1. And what does that mean? That's very basic algebra, right? That means I'm plugging in a 1 for X up here. So I'm going to go H of 1. And what do I get? I get 6 minus 41 minus 8 plus 7. All right, now I don't really care what that may be specifically. All I care about is whether or not it equals 0. And this clearly does not equal 0. So I move on. And let's go h of negative 1. All right, so I'm plugging in a negative 1 up there. That's negative 6 minus 41 plus 8 plus 7. Well, that doesn't equal 0. I don't have to do the actual calculation. I can just look at it and see I've got positive 15 and a whole bunch more negative. It's not going to be 0. All right, so let's try another one. I'm going to stick with the integers first before I get to any fractions, certainly. So I'm going to go h of 7. All right, this is going to require a calculator for this. So 41 times 7 squared. Actually, need to give myself some room here and erase some of these. I can come back to them if I need to. Minus 41 times 7 squared minus 8 times 7 plus 7. Okay. Well, let's see here. I think, yeah, I'm definitely going to pull out a calculator on this. So there's a little bit of simplifying. Now this looks promising, right? 2058 plus 7. What is that? That's 2065 minus negative 2009 minus 56 is 2065. So that equals 0. Okay? So we've got this case where we've got a P of C equals 0. H of 7 is equal to 0. So that means, using the factor theorem, that x minus 7 is a factor of h of x. Okay? All right, now let's look at what we're going to do with that information. Okay, so let's pause here for a moment and just remember what we're trying to do. We're trying to solve this, which means we're trying to factor it. And here I have found a factor, but I want the other factors. And so how do I do that? If I know that something is a factor of something else, like if I'm looking at 63 and I know that 9 is a factor of 63, what do? I divide 63 by 9 and get 7. So since I know that x plus 7 is a factor of this polynomial, how do I find the other factors? I divide. I'm going to divide this, since it's in this convenient form, x minus 7, I'm going to use synthetic division. So let's do that. I'm going to go 7, and then I got 6x cubed minus 41 minus 8 plus 7. I bring the 6 down. 7 times 6 is 42. Add, and I get 1. 7 times 1 is 7. Add, and I get negative 1. 7 times negative 1 is negative 7. Add, and I get 0. And that better be what I got. I better get 0 because that's the remainder. And I knew it. The remainder should be 0 because x minus 7 is supposed to be a factor. All right, now, so with all the information that's on the page now, I can say this. I'm going to draw an arrow down here and say that this is equal to x minus 7 times 6x squared plus x minus 1. Okay? Well, now what? Now I'm down to a quadratic. And what can I do? I can either factor it or I can use the quadratic formula. So this is a really good place to be in, trying to solve a polynomial. I'm going to look at factoring it here. I think 3x and 2x is what I'm going to go for. And then the minus 1, I got to use a plus 1 minus 1. I'm seeing plus 1 minus 1. Let's check that. So I've got 6x squared. I have plus 3x minus 2x is 1x. And I've got minus 1, so it does factor to that. And then I've got my solutions. So my solutions from the factors, you know how to do this, right? The solutions are 7, 1/3, and -1/2. So that's a pretty big problem. But there's really only one new concept in it. All the other concepts are being smashed together in this one problem. The one new concept is the rational zero theorem, and that's that part about the constant over the leading coefficient. Everything else we've seen before. So let's try and put it all together, apply the new concept, and try and solve some of these higher degree polynomials that can't be factored.